of air conditioning units. When you rent a space, if any hotelier is here, and the guest leaves the space, the room, occupancy sensors can be used to automatically shut down the air conditioning system or adjust the temperature to a nice cool mode rather than a freezing mode that the guest says, okay, let me just crank down this thermostat that when I return to the room, I return to a nice cold room. What the sensors can do is say, no, when you leave, rather than you're leaving and setting the temperature controls to 23 degrees centigrade, we will bump it up to 24 degrees or 25 degrees centigrade. You will still return to a comfortable room, but not a cold room. But the owner and the operator saves money in that regard. So occupancy sensors can save up to about 30% in electricity. And I spoke about the variable speed control. Roof insulation. Now, roof insulation is not being applied effectively in our environment. Most of our buildings have 3 floors or 2 floors with air conditioning blaring. Believe you me, insulating the roof can effectively reduce your cost, your operating cost. It can effectively reduce the purchase price of a new replacement unit, maybe a more high efficiency unit, right? So, and what I noticed is that we have locally businesses that apply spray type insulation on roofs, be it metal roof or concrete roof. And this is being applied to great effect, not only from the standpoint of energy saving, but also from the standpoint of the improvement of the reliability, the longevity of the roof structure. Okay, so it's very, very important that roof insulation be pursued. That's a slide of what the controllers look like. That would save about up to 35% for hotel rooms. And that would be seen on the wall. We did a job at a particular a high-profile company in Jamaica where we converted the air conditioning system from being cooled by air to be cooled by water. So retrofits can take place on air conditioning systems that will make a big difference. So we had a job where we converted the same unit that you see on the left is on the right without the air cooling section. And we then converted it to water cool section. We see that dark. Yes, this here is a water cool section. We converted this unit, the same one, to water cool. But let me quickly go into this aspect of discussion too, where you can make ice at night. Your air conditioning systems, for those that are the commercial and industrial installation, you can make ice or what we call build ice at night, and then utilize that ice that is built overnight or on weekend to cool the building during the days without the use of the compressors, which is a high cost part of it. And by making ice at night, JPSCO has a special rate known as the time of use rate. Are you familiar with that? Some of you, I'm sure, are. But the JPSCO has a time of use rate where they will charge you less for electricity. I would like to see them charge even lower. But they have that program where they charge you less for electricity that is utilized during the off-peak period, which is between 10 p.m. to 6 a.m. And by building ice at night during that period and then utilizing the ice to cool the building during the day, you're home and dry in terms of your savings. Tremendous savings can be achieved. It's being done right here in Jamaica. But how many of you know? Maybe not many of you. But that is a possibility that I would like to see, for instance, every commercial bank having an ice storage system. Every cooling system that is more than, say, 30 tons of cooling, for those who are technical, should have an ice storage system where they run the compressors during the night to make ice and then shut down the compressors at 6 a.m. and have the ice cool the building. These are well-known energy efficiency measures, that makes a lot of sense. So you can also utilize the ice bank system to avoid heavy investment in additional air conditioning unit if you're expanding your buildings. You can therefore, because the air conditioning system that you now have serving your buildings, if you double the size of the building, you can run the AC unit at night to build ice. And the ice would be used to cool the new section, which of course will be built more efficient than the previous one. And without you having to invest in additional air conditioning. So when you speak to your engineers who will be talking to you in terms of your investment in expanding your plant, and I'm hoping that most of you will so that I can get a job when you expand your plant, this is really a nice route to go, right? So, and that's a significant cost savings, buying tanks rather than buying new air conditioning system. Of course, it has to be chilled water. But now, again, here is this EER cropping up again, right? Where equipment selection runs like this. You should be advised on either the COP or the kilowatts per ton or the EER. You will observe that as the equipment EER increases, the efficiency increases as well, where you use less kilowatt per ton. The key question that operating facility owners should ask when you're talking about air conditioning is whether or not the EER is better than the competitors, whether or not the COP is better than the competitors, okay? Whether or not this type in COP is better than that type in COP. And by asking these questions and getting the answers, all you have to focus on is the higher number. What is the highest number I can get? What is the biggest bang I can get for my buck when I'm buying new air conditioning units? So it's no longer a matter from today, now that you're informed, no longer a matter of just say, boy, this one prettier than that one, or this one is cheaper than that one. It's not a matter of what is cheaper. It's a matter of what is more efficient. Because the cost of your air conditioning system is not just in the initial investment, but the running cost over time. You're looking at 10 years running cost, as against saving a few bucks, or maybe thousands then, in your initial investment. What are you going to pursue? So that question needs to be addressed, and the easy way to do it is to ask the suppliers, what is the EER, what's the COP, what's the best COP my engineer can advise me on, and how much is it going to cost, in both investment and running costs. Do not shy away from utilizing central air conditioning systems, especially chilled water systems, which we're not seeing much of lately. In the 70s, when more serious engineering was being done in air conditioning, and in the 80s, when very serious air conditioning work was being done by our local engineers, we saw the introduction and the utilization of chilled water systems. Chilled water systems can be operated far more efficiently than the regular mini splits. Take, for instance, this hotel should have, and it's not a criticism of the hotel, you see, I'm just using it as an example, but this hotel should have a chilled water system where every room is cooled by a chilled water fan coil, and this space cooled by an efficient air distribution chilled water system that will introduce the fresh air, this 20 CFM per person, at half the price, half the electricity cost. That's what we're looking at. That is what we're looking at. By just utilizing the proper engineering approach, the proper unit applied to the space activities. You will have to decide, do I purchase a system that is going to cost me double my competitor if he purchases a more efficient type? Can I catch up? Remember, you're at 60 to 80% of your operating expense. Can you catch up with your competitor